So we will start today to do review problems on chapter 3. We will start by the first problem. The springs on the rope assembly are originally unstretched when theta equal to 0 degrees. Determine the tension in each rope when F is equal to 90 lb. Neglect the size of the pulleys at B and D. So what we have here, we have a system that is attached to two springs, and the springs are rolling through cables over pulleys and meeting at point A. Okay, so to ensure equilibrium in this problem, we should find what will be the resulting tension in each rope. So F is given, F is equal to 90. We have two unknowns, the tension in each cable, and it's clear from the figure that the tension in cable AB is equal to tension in cable AD due to the symmetry. Okay, so if you write sum of X equals 0, you will get that the forces are equal. And concerning the second unknown is the angle theta. So here I can say from symmetry that T1 is equal to 2, or I can say this from sum of X. Okay, so you can start by saying due to symmetry T1 equals to T2, or also you can say sum of X equals 0 will give me T2 cosine theta minus T1 cosine theta equals to 0. Since we have the same angle theta, then T1 equal to T2. Now, in order to find T and theta, we need two equations. The first one will be by doing sum of forces along Y. So if I do sum of forces along Y equals to 0, what do I have along Y? I have the projection.
Minus F.
Yes, I have the projection of the two forces, and I have minus F. So it's plus 2T sine theta. So it's 2T sine theta minus F equals to 0. So the first equation relating T and theta is 2T sine theta equals to 90. Now, I need a second relation between T and theta. Who will give me what will be the relation between T and theta? What should I do?
Hooke's law.
Okay, very good. So I should use that the tension T is equal to K times delta L. But how to find delta L? Look, they told us, yes, they told us that originally it is unstretched when theta equal to 0. So when the cable was in this position, the spring was unstretched. So the stretching of the spring will be due to what? Will be due to the variation of length of this part. Okay? So if I call this point A0, then the stretching of the spring delta L can be written as the difference between AB and A0B. So delta L is due to the variation of length of AB. So it's AB minus A0B. And for AB, the length is equal to what? Look at your figure. I can express AB function of the angle theta, because in this right triangle, I can write that AB cosine theta equal to 2, So AB is 2 over cosine theta. So this is equal to K, which is 30, times 2 over cosine theta, minus A0B, which is 2. In this way, I got a second equation uh, as a function of t and theta. So now I have two equations with two unknowns, and I can solve. Okay, don't worry about the solution of such problems. And here, what you can do is that you can express t function of theta and replace in the second relation. You will get a relation between sine and cosine. Okay. Uh, all I want you to do is to reach this step. No need to solve for theta. It's fine. In general, how we solve these equations, we can put on the calculator. You have an option in the calculator to solve an equation. So your final result will be uh, tangent of theta minus sine of theta is 0.75. So to solve such equation, you can do it on the calculator by putting the equation, and it will solve for theta. Or you can do it by trial and error. So you will try several value of theta until, for example, if you start by 50, let's say, you will obtain a value around 0.75. If you choose 60, then 0.75 will be in between. So you continue to reduce your interval until reaching the solution. Okay, but of course, I will not give you such complex calculation. Just what is important for me is to reach this stage. Okay, and in the exam, I will give you equations that you can easily solve using the calculator.
Doctor,
Yes.
but I tried it and I did not know even كيف وصلت لتانجنت تيتا minus ساين تيتا، يعني ما عرفت كيف أبدا حلهم.
Okay. Look, you have these two equations. Okay. So what you do is you should replace t by its function of theta in this equation. So if you do here 2 times, I will replace t by its value. T is 60, so it's 2 times 60 over cosine theta minus 120. Okay, so this is if you want, this is 2t. Then I should multiply this by sine theta, and it is equal to 90. Okay, so now if you do the expansion here, what do you have? You have first 2, it's 120 sine over cosine. What is sine theta over cosine theta? It's tangent theta.
Tangent.
Okay, so tangent of theta, and minus 120 sine theta equals to 90. Now, if you take 120 to the other side, you will get that tangent of theta minus sine of theta equals to 90 over 120 equals to 0.75. Okay, so it's just a replacement method to get this relation.
Okay. Thank you, doctor.
Welcome. Any question on this problem? Okay.
Dr. Anna, it's not a specific question,
Yes,
but
tell me.
I'm not really understanding how to start thinking about how to solve it.
Yeah. Whenever you have an equilibrium problem, okay, try to find what is the point by which pass the different forces. So here you can see that A is the point joining the forces of the problem, which are the force F, which is given. Okay, so since you know something here, you know the value of F. And what is your purpose? Your purpose is to define the tension in the rope. Okay, and the tension in the rope is related also, it's a force exerted on it. So in order to find the tension in the rope, you should write the equilibrium equations at point A. Okay, but when you write the equilibrium equations, you will not solve completely because you have T1, T2, and theta. The symmetry or sum of x will give you that T1 is equal to T2, and sum of y will give you a relation between T and theta. So the equilibrium equations are not enough to solve your problem. Whenever you need an extra relation, you should look at your problem to see what is the information that I didn't use yet, which is that this tension in the cable is also equal to the tension in the spring, because here, as you can see, the spring is related to the rope. Okay, so here you have, it's like one cable if you want. So the tension here will be equal to the tension developed by the spring. Okay, and the tension developed by the spring is due to its stretching. So this will give you an additional equation, since you know that the tension developed by a spring can be calculated from K times delta L. And delta L is due to what? Initially, when point A was here at its initial position, the springs were unstretched. So when A will move downward, okay, this length will change, and this will cause a stretching of the spring. Okay, this is how you should think. So you think step by step in order to come up with enough number of equations to solve your unknowns.
Okay, thank you.
Well. Okay, another problem. A continuous cable of total length 4 meters is wrapped around small pulleys at A, B, C, and D. If each spring is stretched 300 millimeters, determine the mass M of each block. Neglect the weight of the pulleys and force. The springs are unstretched when D is equal to 2 meters. So what do we have here? We have, as you can see here, you have one cable that is rounded over 4 pulleys, and in total the length of the cable is 4 meters. So here, due to symmetry, each segment will be equal to 1 meter. So we know here that each part will be of 1 meter. Now, they are saying that in order to, in this case, in this figure, we have that each spring is stretched 300 millimeters. Okay, so at this position, I have stretching of my springs. Now, how to, if you want to determine the value of D here, what is this distance? I don't know it, but I have an additional information given in the problem. They said the springs are unstretched when D is equal to 2 meters. Okay? Look, to have D equal to 2 meters, in which location should be B and D? Look,
in the middle.
yes, at the middle, because each part of the cord is 1 meter. So if I want to have this total distance between A and C equals to 2, then B and D should be just at the center. Okay? So if I want to represent the unstretched position, for the unstretched position, this is C. B should be just at the middle, and also D. So here at the middle I have B and D, and down I have A. Okay, so initially, to have the springs unstretched, I have this is 1 meter, and this is 1 meter. This will give me an initial distance between pulleys C and A equals to 2 meters. Okay, so since they said at the unstretched lengths, the distance separating the cables is 2 meters, which is 1 plus 1. I deduced that for this position, B and D were at the middle. Now, in order to obtain the final configuration, what I should do is that I should push B to the left, and I should push D to the right. Under this effect, what will happen? C will go down, and A will go up. Okay? Now, since they gave me the stretching of each spring, they said that each spring is stretched 300 millimeter. This means that C will go downward 0.3 meter and A will go upward 0.3 meter. This analysis will allow me to determine what is now the new distance D separating C and A. Okay, so what will be this distance here? It will be 2 minus 0.6, so it will be 1.4. Therefore, it is divided into two parts from the center. I have 0.7 meter here and 0.7 meter here. Why I am interested in D? Who will tell me? Why should I know D? It will help me in finding what?
Delta S.
No, delta S is given. It is 300 millimeter. It will give me the angle, okay? Because look, what is my purpose here? My purpose is to calculate the tension in the value of the mass, okay? So let us think step by step. If I want to find the mass of the block, this means that I want to find its weight. And to find the weight, what should I know? If I tell you this weight is in equilibrium, how to find the weight? It should be equal to what?
To the tension.
Exactly, to the tension in this cable, okay? So let us call this tension T1, okay? Now, my problem is to find T1. If I want to find W, I need T1. And if I want to find T1, I should do the analysis of forces at what point?
B and D.
Exactly. Or B or D, because I have symmetry here. Okay? So let us say why I thought I should do the analysis of B. Because look, this cable is starting from here, rolling over the pulley and continuing here. So the tension is the same over the whole cable. So now at point B, I have T1. Okay? So if I want to draw the free body diagram at B, I have T1. Guys, please mute your microphones if you don't have questions. Can you hear me, please? Please mute your microphone. So I have T1 here, and I have the tension. I have the tension in BC and BA. Okay? So this is T2. Yeah, monsieur. Please, can you mute yourself, please? The one who is talking. Mute yourself, please. So we have here T2. And by symmetry, we can say that we have here, or by symmetry, we can say it, or since it's the same cable, okay? So since you have the same cable here that is over the pulleys, then the tension will be the same everywhere in this cable. So this is T2 and this is T2. But in order to find T2, okay, I need to write first the equations of equilibrium of B. And in order to do this, I need an angle. I need to project my forces. So I need to know what is this angle here. Okay? And to know the angle here, I need what? I need the distance D. Okay? So this is why I need to find this distance. Because now, if I know that this distance is 1.4, then this part here, this is 0.7, okay? And I know that this length is 1, so I can find this angle, okay? I can write, if you want, this angle here, let's say I call it alpha, for example. So if this is alpha here, yes?
Because the system is symmetrical, we can say that T2 is T1 over 2?
No, never. Why? It depends on the angle. No,
They
it will
have the
depend.
same
It will depend on the angle T2 is doing with the horizontal. Because of symmetry, you can say that T2 is the same. Yani, T2 up is equal to T2 down. And of course, it will be the case because it is the same cable. Okay? But you cannot say that T1 is T2 over 2, no? Because look, it will depend on the angle here when you do the projection. If this angle will vary, the relation between T1 and T2 will vary. Okay? So if I call this angle alpha, then when I project on x-axis, what do I get? I get that sum of x equals to 0. So I have minus T1 plus 2T2 cosine alpha equals to 0. And how to find alpha? Alpha is, I can find it by saying that tangent of alpha is equal to 0.7 over 1, okay? Which is here in the problem, they called this angle theta, if you want. Okay, they called it theta. So it's equal to 0.7 over 1. Sorry, not tangent, it's sine alpha, okay? Because it's the opposite side over the hypotenuse. So sine of alpha equal to 0.7 over 1. And I can find the value of alpha in this way, okay? Now, once I find this relation, I can see that it's not enough for me because I have two unknowns, T1 and T2. So how to continue? How to find T2? What should I do? Look at you.
We still
Yeah.
did not use k equals 500.
Very good. We will use the information about the spring. So now which point we will study? We will study now the equilibrium of which point?
Point A.
C.
Point A, exactly. Because point A is also subjected to T2, okay? So I have T2 and I have T2 here. Plus I have the force of the spring, but the force of the spring, I can calculate it because I know the stiffness K and I know the stretching of my spring, which is 300 millimeters, okay? So now, after, so this is T2 and this is T2. And we already calculated together the angle alpha, okay, or theta here, they call it. So already we know the angle theta, so we can do now the projection at A. So from point A, I can say that sum of y equals to 0. And by projecting on y, I have 2T2 sine of alpha or theta is equal to minus, if you want, the tension force of the spring, which is minus K, okay, times delta L equals to 0, okay? And delta L is given, so K, I know it, K is equal to 500 Newton per meter. And delta L, don't forget to convert, okay, K is in Newton per meter, and delta L is given in millimeters, so I convert it to meter. So delta L is equal to 0.3 meters. And this equation will allow me to calculate T2. Once I know T2, I can replace back in the equation of B, I get T1. And once I get T1, I say that T1 equals to W. So M is T1 over G. Okay? Any question on this problem?
Doctor,
Yes.
can you please repeat how we got the length 0.7 meters?
Yes, of course. They told us in this problem that the springs are unstretched when G is equal to 2. So this will allow me to determine the initial position of C, A, B, and D. Okay? Look, each cable has a length of 1. So this is 1 meter and this is 1 meter. to have a total distance separating A and C equal to 2, the two cables BC and BA should be aligned. Okay, should be along the same line, because in this way you will have 1 plus 1 as a distance separating C and A. Okay, so the only possibility to have a total distance separating C and A equal to 2 meters, the cable should be aligned. Therefore, B and D should be at the center. Okay, so initially pulley B and pulley D are at the center, and the total distance separating C and A is 2 meters in this case. Okay, now what will happen? What you will do is you will stretch the springs. When you stretch the springs, C will go down, A will go down, okay, and B and D will go in opposite directions. Okay, so the new position is the following. You know that the stretching is 300. This means what? That point C should go downwards 300 millimeter or 0.3 meter, okay? And A should go up 0.3 meter, okay? So in order to obtain the stretching of 300 millimeter, what will be the new length between C and A? If initially the separating distance was 2 meters, and C will go down 0.3 to give a new point C prime, a new position of C, and A will go up to give a new position of A, then what will be the resulting separating distance? It's 2 minus 0.6, it's 1.4, okay? So now this distance is 1.4, and if I consider from the center line, the distance will be 1.4 over 2, which is 0.7. Okay, and knowing this distance, I can calculate this angle theta by saying that sine of theta is 0.7 over 1.
Thank you, doctor.
Welcome. Any other question?
But doctor, where did we use when we calculated the angle theta? Where did we use it?
We use it for
Afterwards.
projection of forces. So when you write sum of y at A equals 0, you need this angle. Look, you need it at A and B. So when we consider it point A, when you do sum of y, okay, you should project your forces. So you should know this angle. The projection on x will be cosine theta. The projection on y of these forces will be sine theta. Okay, so you need to know this angle to be able to project your force on the xy axis. And also we used it in B, because here in B, to project this force along x, you need this angle. And this angle here is the same as here, okay? Because you have parallel lines. Since you have parallel lines, this angle here is equal to this one, okay? So we need it for projecting forces on the axis. Another problem. A scale is constructed using the 10 kilogram mass, the 2 kilogram band P, and the pulley and cord arrangement. Cord BCA is 2 meters long. If S is equal to 0.75 meters, determine the mass D, neglect the size of the pulley. Okay, so here, what we have is, we have a system that is used to measure the mass, okay? It consists on the following. Knowing if we can measure S, we can deduce the mass, okay? So this is like an instrument for measuring of masses as a function of the length of displacement of the ball. So how should we think here? First, they said that the cord BCA has a total length of 2 meters, okay? So I can say that BC plus CA, and of course, since I said neglect the size of the pulley, so this part here of the cord is of negligible size, okay? So I can say that BC plus CA is equal to 2. And since S is given to be 0.75, okay, and S is equal to CA, so I can deduce BC. So BC is equal to 2 minus CA equals to 2 minus S equals to 1.25 meters. Okay, so now I know that this is 1.25 meters, and I want to find what will be the mass in D. To be able to find the mass in D, I am interested in the weight if you want, okay? And the weight will be applied at which point? You know, the weight of the system will push B down, okay? So here, the effect of the system attached to B is that the total weight will push down on B. So here I have W total. And I have two tensions, which are the tension in this cable. So this is first cable, and I have another tension here. So let us call them T1 and T2. Let's say this is T1 and this is T2. Okay. Now, if you want to solve, it's clear that B is the interest point. So what I will try to do, I want to project my forces, okay? I want to project T1, T2 on X and Y. This is why I need angles, okay? I need to
Doctor?
know, yes?
excuse me. أنا كنت حطيت الويت من
Yes.
D downward. So أنا عادة I have the right to إنه زيح the vector on the same line يعني علي لفوق.
Okay. You mean,
لا عم بسأل
I
فينا
didn't
حرك
understand.
الويت؟
Can you please repeat the question?
Okay. Can I move the vector W بس إنه on the same axis?
You mean you want to put it like this? Yeah.
No,
Like
it's
this?
just a question. No, it's just a question because إنه أنا كنت حطيت ال W على D.
Okay, it's fine. Look, why I put it at B. If you want to do it in steps, look. First, you can take a system D plus P. Okay, D plus P, it is W total. Okay, and W total is in equilibrium due to these two, due to the tension in these two cables. Okay, these two tensions can have a resultant. They have a resultant force, which will be opposing the weight. Okay, so if you want by action reaction, you have here that this cable is attached to B. So what will be the total action on B? The total action on B will be this force T1, but downward, okay, and force T2 downward. So the summation of these two forces will give you what? Is the weight. This is why I directly put the weight here. Okay, did you
Okay,
understand?
thank you.
Okay.
Yes,
But
doctor.
yes, if you want to be very, if you want to go step by step, you start by D plus P, and then you say that the resultant in the two cables is opposing the weight. This is why the action on B will be equal to the weight. Okay. So if I want to draw again the free body diagram at B, I have here, if you want, I will put it as the resultant force, R, okay, resultant force of the two cables, which is equal to the weight, the total weight, okay, and I have tensions in these two cables. I have tension T1, let's say, and tension T2, okay. Now, if I want to continue my problem, what should I do? Whenever you have forces, you need to determine their directions to be able to do projections, okay? So you need to find angles. What are the angles of interest here? You have two angles of interest. the angle of T1 with the horizontal to be able to project. Let's say here they call it phi, okay? And the angle of T2 with the horizontal, they call it theta. Now, how to find phi and theta? Look, this angle phi is equal to which one? You have these two parallel lines, and you have two alternating angles. So this angle here is phi, okay? So phi here is equal to phi here. And then for angle theta, I have that the angle here is theta, and also I have, due to parallel lines, I have these two alternating angles. So this is theta. Now, to be able to calculate theta and phi, what can you use?
Can we use the
Sine law.
Very good, sine law, okay? But look, for sine law, pay attention. For sine law, I need to know at least one angle. Do I know one angle in my triangle?
cosine law?
Cosine law, okay? I should use cosine law. Why? Because I know all sizes of my segments, okay? Look, let me clear it to see it again. You know that this distance is 1.5 meter, and this distance is also 1.5, okay? So you just need, and you know that this distance here is, we calculated together, it's it's also 1.25. Yes, it's 1.25, okay? So here, to find this angle, I can use the cosine law. So let us write it together. The cosine law will give us what? From cosine law, I can write that 1.25 square is equal to 1.5 square plus 1.5 square minus 2 times 1.5 times 1.5 times cosine phi, okay? So from the cosine law, I can calculate the value of phi. And once I know phi, no need to use sine or cosine to find theta. Why? Because look, this is an isosceles triangle. I have 1.5 and 1.5. So once I find phi, I can easily get theta, okay? Because these two angles here are equal to theta, okay? So I can say simply that theta is equal to 180 minus phi over 2, okay? If you didn't pay attention that it is an isosceles triangle, you can find theta or from cosine law, as you did for phi, you do for theta, or now you can apply sine law, because you can say that 1.25 over sine of phi is equal to 1.5 over sine theta. So also it is, so you have several methods to find theta. You can use cosine law again, you can use sine law, or you can use that it's an isosceles triangle. So if I know phi, I can deduce the value of theta. Okay? Any question until here? Look, I will open a new session to continue, okay? Because time is over.
Doctor.